Good morning to all dignitaries, guests, and delegates. With great joy and immense pleasure, I welcome you all. I feel privileged to extend my warm welcome to all presented here for the AICTE Training and Learning Academy's 1 week faculty development program on issues related to power plant. I, Sona Lal Chandani, on the behalf of Department of Mechanical Engineering, Government Engineering College Bilaspur, welcome you all on third day's first session. I am overjoyed to take the opportunity to introduce our speaker of this session, Shri P. Kanagvel, Director and Head in Development and Training Division, National Institute of Wind Energy, Chennai. He is having diverse educational background with basic degree in geology, post-graduation in library and information science, diploma in IPR, diploma in wind energy, doctorate in library and information science, and diploma in renewable energy. He has received the various prestigious awards such as 50 Most Influential Sustainability Leadership Award, Excellence in Teaching Award 2017, and so on. He has successfully organized 39 national and 39 international training programs as course coordinator. He has 22 plus years of experience in various fields, mainly in wind energy. Presently, he is the director and head of skill development and training division of NIWE. He will be addressing the session on topic wind energy technology. Sir, I request you to kindly deliver your speech.
Thank you, Sonal, for the brief introduction about me. And, a green good morning to all of you. I hope I am audible.
Yes, sir, you are audible.
Yeah. First of all, I would like to express my gratitude to the management and the organizing team this 5 days FTP program for giving me the opportunity to be in this online platform to deliver the lecture on wind energy technology aspect. And I hope the coming 2 hours I will give you useful knowledge transfer on wind energy technology aspect. I'm really very happy to be part of this event, even though we are a little busy, because we normally get to meet only the bureaucrats and the core engineer who are all working in the wind energy sector. This is a very rare opportunity for us to meet the young minds, the academic people who are spreading the useful knowledge transfer for the development of our country and even development of the world. So with this small brief, I will try to share my presentation. Presentation is visible. I'm audible.
Yes, sir.
Yeah, we'll once again I welcome all the participants and thank the organizing team for the opportunity. So I have structured my presentation such a way that we start with a small background of energy and the impact of energy on the environment, and why we are going for renewable energy sources, and more on wind energy technology aspect. So that's how I have structured my presentation. We all very well know that energy become part and parcel of our life. Even 5 minutes power cut is intolerable now. We started leading such a kind of life with the help of the electricity. So 5 minutes power cut is very difficult to manage us. So that kind of life we are leading. This is the world energy mix. I have a data from 1965 onwards. If you look back, almost all these years, the fossil fuels are supporting the energy demand, and because of the increased awareness about the global warming environmental issues, we started producing power from alternate energy sources, particularly renewable energy sources. And if you look at the global electricity generation, so almost more than 70% of the energy we are meeting from the fossil fuel and nuclear energy resources, and close to 28 percentage of the power comes from renewable. Among renewable, we can see here hydro is contributing in major way, next to hydro, wind, and other renewable energy sources. So having a large amount of contribution from the fossil fuel is not at all good for environment, which will not lead to a sustainable development, which we all very well know. Let's see in coming slides as well. This is about Indian energy installed capacity. So right now we have close to 4 lakh megawatt installed from different sources, and at par with the world, we are also having large amount of contribution from the fossil fuel, basically thermal, majorly thermal based power plant. And next to that, we have about 25% of the contribution comes from renewable energy, and hydro 12%, nuclear is just 2%. So this is the Indian energy installed capacity. And we all very well know that if you produce electricity from the fossil fuels, the carbon dioxide is emitted in the process, due to which the global average temperature is increasing, which is nothing but the global warming. Because of the temperature rise, last few decades, we started seeing a lot of negative effect on the environment. And any participant help me, what are the negative impact we started observing due to the increased temperature, like global warming? So I would like to have an interactive session, and I also inform you that anytime you can stop me for any kind of clarification or doubt. Participant, can you help me? What are the negative effect? No problem. And these are the negative impact because of the temperature rise, majorly due to fossil fuel power plant. The direct impact is melting of ice glaciers. Normally, we have different season in a year, like winter, summer, and so on. During winter, the ice glacier will get formed due to low temperature, and during summer, because of the increased temperature, ice glacier will melt. In fact, this is a perennial source for the river in the water, water in the river. Now, because of the continuous rise of temperature, the ice glaciers started melting on continuous basis. Because of that, the sea level is keep rising, and not only sea level rise, there are other problem like biodiversity issues, which is another big issue. We'll not discuss about that here. Time permit, we'll discuss. And see, the continuous melting of ice glaciers uh, increases the sea level, water in the sea level. Recently, you could have learned about the report submitted by World Meteorological Organization under United Nations, saying that many countries are in threat, particularly the cities close to the ocean are in threat. Even India, they suggest informed that about 16 cities are under threat. So it's a big threat for us. The sea level rise. We very well know that 1/3 of the earth is full of water, and even India itself, 3 sides of water. Like we have more than 7,500 kilometers of coastline, and many cities are on the coast. So if this continues, many cities, even in India, will have a big threat. And because of this impact, you see the impact on our health. So nowadays, scientists are coming up with new viruses which are going to be very dangerous for our health. If you look back, I think 10 years down the line, we had come across chikungunya. So once it's affected, we have to suffer like anything for a month, and even many people died after the infection. And after that, swine flu has come, Ebola, Zika. Now we are suffering from COVID-19. So about COVID-19, there are different versions. Even some people are saying it is a kind of biowar, but the scientists have reported that these kind of things comes due to the temperature rise because of the uh, uh, fossil fuel power plant. That is the major cause. In fact, there are different reasons for temperature rise, but the energy production from the fossil fuel is one of the major cause for this system. Then you see the impact on the climate. Nowadays, during rainy season, we are unable to get rain. During summer, the temperature goes up like anything, and everywhere we started seeing a lot of the abnormality. So that is a big problem. In fact, I don't want to tell you in detail, because you know what are the changes happening in the climate. Because you see, those days we used to call the country fellows, olden people, without having any facilities, any kind of now we call educational background. They could able to predict everything exactly. Now we have scientists who had um, 30-40 years of experience in the meteorology department. We have supercomputers and even satellite, but still we are unable to predict exactly what the olden people used to predict. So uh, everything is climate change comes because of the temperature rise. Temperature rise is due to energy production from the fossil fuel. So that's why last few decades everybody started talking about this. You call see any institution, any universities or colleges, they started having a program like training program, a seminar, conference on all these kind of topics. And last 3-4 decades, we can see everybody started talking alternate energy sources, green energy sources, clean energy sources, and advanced one renewable energy sources. And in advanced stage, people are talking about smart grid, microgrid, mini grid. So many terms are being talked about only because of this thing, because this is one of the biggest problem the mankind is facing in this century. And the statement what I made, the energy production is the major cause for the temperature rise. I can prove that from this slide. So this I've taken from a source called co2now.org. So these are the people who record the CO2 activities and report. So according to them, you see here the top, close to 8 billion metric tons of CO2 emitted into atmosphere is because of the fossil fuel power plant as well as cement industry. The cement industry contribution is very less when you compare the fossil fuel power plant, and just 12% is because of the land use activities. And bottom you can see whatever CO2 emitted, where it is going. Close to 50% of the CO2 is emitted into atmosphere, and about 27% of the CO2 is absorbed by the vegetation like plants, trees, and all, and remaining 26% goes to the ocean. So 50% of the CO2 emitted is going to atmosphere, which leads to the temperature rise. You know, we have the greenhouse effect. which is dropping the heat. Because of that, the temperature rising up. So this is a country-wise emission of CO2. So fortunately and unfortunately, India also in the top 5 countries who emits greenhouse gases. So I cannot say only energy production from fossil fuel is the complete reason for the all the negative effect what we are seeing. So we can see here, these are the reason why the greenhouse gases are going into atmosphere, which leads to the temperature rise. So we started doing a lot of deforestation activities. Because of the increased population, we started doing a lot of agriculture activities which emit methane, and a lot of landfill activities and emission coming out from different factories of various kinds for various purposes, and emission coming out from the fossil fuel power plant and also the transport sector. So these are the reason the greenhouse gases are emitted enormously, which leads to the temperature rise. So again, I can prove the statement: the energy production is the major cause for the temperature rise. From this graph, you can see this graph I've taken from a source called Science Blog, the Science News Blog. So according to this source, you can see 94% of the CO2 rise into atmosphere is because of the energy production from the fossil fuel. So that's why everybody started looking at the energy production. Because now we cannot avoid the production of energy, because we started habituating with the help of so many equipment, machineries, which needs a lot of power to work actually. So if we allow the current temperature rise on continuous basis, maybe after a few years later, the temperature will go off like anything, which will not be feasible for us to live in the earth. In fact, this information I've taken from a book called 6 Degree, Our Future on a Hotter Planet. Mark is the author. So this author has taken a reference of yeah, before that, participant, anybody help me, what is the global average temperature, how much it is? Any help from participant? Please feel free, and we'll have interactive session. No problem. So around 15 degrees Celsius is the global average temperature. We'll have plus or minus also a little, maybe 1% plus or minus. And this author has taken a reference of the global average temperature of the year 2012. So every year we record global average temperature. So 2012, the global average temperature was around 15 degrees Celsius. It was 14.7 or something. So we take it as a 15 degrees Celsius was the global average temperature in the year 2012. So he says from that level, if you allow 1 degree Celsius rise, for example, it reaches to 16 degrees Celsius, so we'll be losing fresh water. The low-lying coastline will get flooded like anything. If we allow 2 degrees Celsius rise, for example, it reaches to 17 degrees Celsius of global average temperature, we may have a heat stroke. The forest fire will happen like anything. It is not that it is not happening. The frequency of the occurrence will be more. Now we are hearing here now and then. So the temperature rises to 70 degrees Celsius of global average temperature, we will be seeing frequent forest fire. And if we allow 3 degrees Celsius rise, normally the plant absorbs CO2 and emit oxygen. Instead of that, it will start doing in opposite way. So it will be a very big challenge for us for our own respiration. In fact, now you all know everywhere the air pollution is happening. And last few years we are listening from Delhi. Delhi, a lot of air pollution is there. Not only Delhi, so many cities in India as well as foreign countries are suffering from this. And that's why every country is now they are coming up with the accent clubs actually, If really any one of you would like to start a business, you can go for this. The selling of oxygen, it is going to be a good business, because that kind of the air pollution happening everywhere, and we can definitely do well if you go for this business. In fact, you see, there will be a club where if you go, you have to get a membership, like being fined $1,000, and if you get into the club, there will be a room with full of pure oxygen. You can go and rejuvenate yourself and come back. So this is expanding all over the world, and in fact, if this situation continues, so right now when we go out to shopping mall or office, we always carry a bag with a water bottle. So this continues. Instead of water bottle, we need to keep a oxygen cylinder. Right now, cylinders are kept only in the hospital for treatment purpose. Uh, uh, this situation continues. We have to have in our bag also. So whenever you feel suffocated, you have to inhale and survive for some time. That kind of situation may arise. That's what people are threatening. And if we allow 4 degrees Celsius rise, for example, it reaches to 19 degrees Celsius of global average temperature, so we cannot stop the global warming. So up to 4 degrees Celsius of global average temperature. So after that, whatever mitigation you do, whatever process you do, you cannot stop the further rise. So 6 degree has been predicted. It is end of our life. So you see the threat. So that's why everybody talking about the global warming, climate change issues and all. So because of this effect, we have the sea level is keep rising. This is the 50 mm is the global average sea level rise. Some places 200 mm, some places 100 mm. So it keeps varies place to place, but the average is 50 mm. So this continues. As I said, many cities close to the ocean will go into, and in fact, you see, India, many cities are there on the coast. Uh, Chennai is having second longest beach in the world, the Marina Beach. So if this continues, we have to read in a history. There was a city called Chennai. It has a beautiful marina beach, which is of second largest in the world, which went into the ocean on this particular year because of this effect. So these kind of extreme things will happen, and because of this effect, uh, every year we are losing about 50,000 species, which means every 2 years we are losing 1% of the species available in the earth. So this is another biggest problem. I was talking about the biodiversity issues. So we all know very well. We cannot simply leave that this is a small ant, this is a small bird, which is not going to contribute anyway in my life. No, each and everything created on the earth is doing its own contribution to maintain the equilibrium. And see, we know the life cycle, the food chain. So everybody depend on somebody. If you have break in the food chain, it will be very difficult to maintain. Uh, it will be very difficult to live in the earth. So this is a very big problem. That's why everywhere now they are increasing the forest cover. So every country is trying to increase the forest and protect the forest. Why normally the forest people have full power. We cannot enter into forest without their permission, and we cannot do any activity in the forest. Why? What is there in the forest? Nothing. Small animals, birds, or trees. Why it is not? So to maintain the biodiversity issues. So after seeing all these negative impact, so people started thinking about alternate energy sources, because the major amount of electricity we are producing from the fossil fuel, which is damaging the environment, and by producing the increasing the temperature. So to avoid all these things, to mitigate this, the people started looking at alternate energy sources. So while searching for alternate energy sources, these are the factors, these are the objective we have to keep in mind. So what we need for going for alternate energy sources is to have a clean environment. A lot of pollutions are there, a lot of problems are happening. So our objective is to have a clean environment. Then now the electricity is become part and parcel of our life. Without electricity, it's very difficult to lead our life. So we need to have a continued power. So we have to have a continuous power supply, and we have to identify a source which is perennial one, which has huge potential. And another factor is we need to identify a source which is alternate energy source. If you convert that source into electricity, there should not be any kind of greenhouse gas emission. So we have to identify that kind of source, and you identify any source which will lead to the decentralization, which will lead to a rural development, which will support for the socio-economic development. So we have to identify a source which is alternate to the fossil fuel. That's how people came to renewable energy sources. There are natural resources available. If you produce power from these renewable energy sources, we can definitely take care of all the. So if you produce power from renewable energy sources, which can lead to clean environment, which has huge potential, so we can produce power on continuous basis. There will not be any greenhouse emission. It is locally available, so it can support for the decentralization. Definitely, it can support for rural development, even island electrification, and it will support socio-economic development. So that's how people started looking at renewable energy in major source. And if you see from 2015, we have to double. The prediction says the electricity consumption will be double in the year 2050. You see, in 2015, about 20,000 terawatt hour electricity was our consumption. So in 2050, it is going to double, like close to 40,000 terawatt hour. And how we are going to generate. So all this year, the major contribution was from fossil fuel. So coming year, renewable energy production will go in a big way. Among renewable, wind and solar is going to contribute in a big way. That's what people. So see, right now, non-renewable supports for our energy demand. So maybe after 30 years, almost the fossil fuel sources will go in very minimum, and renewable energy sources will contribute in a big way in terms of energy production. So right now, we have more than 2,500 gigawatt of renewable energy installed capacity. That number one, China having more than 400 gigawatt, and we can also feel proud that India is in the top 5 countries in terms of renewable energy installed capacity. And so this is about renewable energy potential in India. So as you all aware, sun is the mother of almost all the energy resources. So we can go for about 50 megawatt in a square kilometer. 1 square kilometer, 50 megawatt solar power production is possible. And right now, because of the capital investment, we could not go in a big level, but gradually it's increasing. Day by day, the solar power conversion is picking up. Uh, this is the install capacity right now. More than sorry, this is a little old data. Now more than 43 gigawatt install capacity from solar. So next to solar, wind is having good potential, and normally close to the ground, the wind speed may not be good because of obstacles like buildings, trees, and other structural for various purposes. So if you go along with the height, the wind speed increases. So that's why we measure a wind potential different height. So at 50-meter height, we can harvest about 50,000 megawatt, and at 80-meter height, close to 1 lakh megawatt is possible. At 100-meter height, we can go for about 3 lakh megawatt. Recently, we have estimated that at 120-meter height, 700 gigawatt, 7 lakh megawatt potential is possible from wind alone. But right now, the installed capacity is close to 40 gigawatt. And next to wind and solar, we have some potential from bio and hydro, small hydro. We also have installed capacity. Bottom, if you see these three resources like tidal, wave, vortex, ocean thermal energy conversion, and geothermal. So even though we have identified some potential, till now we have not commercially exploited, because the technology is not very well matured, and we do not have a trained skilled manpower to take forward this sector. But still, the government of India is working on to bring the power production from these resources also. Already a lot of pilot projects, and in geothermal, already a lot of works are happening in India, particularly Gujarat is going to have maybe a couple of years later. We can see first geothermal power plant in India at Gujarat. So in fact, now we have crossed 1 lakh megawatt of renewable energy installed capacity. So this is the global wind energy growth. In fact, year on year, the growth is very steady and smooth. And right now, we are close to 750 gigawatt of installed capacity from wind all over the world, which is more than 4 times of the current world electricity demand. This is Indian wind energy growth. So, yeah, India also growing very smooth and steady growth seen in India. Can you please mute yourself, sir? Yeah, this is Indian position in different renewable energy technology in terms of installed capacity. Overall renewable energy installed capacity, India in fourth place in the world, and in solar PV, photovoltaic, we are in fifth place. Solar CSP, sixth place. Wind, we are in fourth place. Almost all the renewable sector, China is number one, except the solar CSP, concentrated solar power. Spain is number one. In fact, now the every countries, the whole world is moving towards energy transition and to mitigate the global warming and climate change issues. And every country is coming up with the like target to increase renewable energy installation, reduce fossil fuel power plant. In fact, many countries have started shutting down their fossil fuel power plant, nuclear power plant, going largely with renewable energy installation in different projects and different aspects. In fact, so countries we used to call the European countries, they are the environment friendly countries because they take care of the environment nicely. And if you see German, they have already target for the year 2030. Next 10 years, they would like to go for 100% renewable energy installation. They will not use fossil fuel power plant and other any nuclear power plant. They will be going for only renewable energy installation and renewable energy generation. Similarly, the countries like Sweden, Canada, they have a target for 2040. Same way, India also having a target. 5 years before, we have come up with a target for the year 2022. So next year, 2022, we had fixed a target of 1,75,000 megawatt from renewable. In that, we'll be having 100 gigawatt from solar, and 60 gigawatt from wind, 10 from bio, and 5 gigawatt from small hydro. So small hydro and bioenergy almost we achieve. Uh, Wind close to 40 gigawatt, solar more than 43 gigawatt. Oh, we'll be definitely achieving the target because a lot of efforts are being put forth by ministry, the government, and all the other the institutions who are working in renewable energy. And recently, our Prime Minister Modi ji has confidently announced that India will have 450 gigawatt from renewables by the year 2030. So that will be about 50% of our electricity demand. That's what the current target. So when we achieve this target, there will be a lot of money flow, and there will be a lot of green collar jobs created in this sector. So this picture tells you right now we are here in 2021. So all these year, a major amount of energy demand were met from the fossil fuel, and uh, maybe after 30 years in the year 2050, we have to come to a position where we completely reduce electricity production from the fossil fuel and increase the production from renewable energy sources. So not only the production, parallelly, we need to concentrate on energy efficiency, energy conservation activities, energy saving activities. Then only we can continue to have a sustainable life, sustainable development, and we really all love our own future generation. If you want to give a better future, a greener, clean environment to our future generation, so we need to start uh, changing your mind to save energy and start using the energy efficient equipment. This is a very very need of the hour. All these slides we were seeing how the energy production from fossil fuel is impacting the environment. That is one side. One side, because of the energy production from fossil fuel, environment is getting damaged. Other side, uh, we are all very lucky or fortunate people to have all the facilities. A lot of countries, if you happen to see, only city side they have electricity access. We enjoy our life. Indian government claims 100% electrified. Even rural place, we have access to electricity. But many countries, on this point of time itself, a lot of people do not having access to electricity. See, I happen to travel to African countries. I had a long road travel. I could not see any the power facility. Even hospital purposes, they do not have electricity. But we lavishly enjoy. And enjoying is not a problem. We lavishly waste electricity. Knowingly or unknowingly, we waste a lot of power. At home, we are watching TV or not, we continuously switch on. We never had a habit of switching off and plugging out anything like mobile charger or mosquito repeller. Even nowadays, TV, AC, everywhere, we use only remote. We never switch off. We never unplug. And it has become a fashion for us to drive our own vehicle to a shopping mall, office mall. So this is the time to change your mindset. Start using mass transportation like bus, train, which consume less, which emit less. And at office, whether we are in our room or not, our fan, AC, light is continuously switched on. So we never had a habit of switching off the monitor and unplugging the computer power points and all. So please, keeping everything in our mind, try to save electricity and try to use energy efficient equipment, because everywhere now we can see star rating on different equipment. Like India, we have a bureau of energy efficiency. They are coming with a lot of policies schemes to support for energy efficiency activity. Like those days, we used yellow bulb, which has been replaced with the CFL. Now people are going with LED, which consume less, and lifetime also efficiency is more. So these kind of activities happening, and they are giving a star rating, 3-star, 4-star, 5-star for all the other equipment. So we will join hands with the government support schemes and support for the keeping clean environment and safety environment to our future generation. So with this, I using this online platform, I request all of you, please try to change your mindset to save, conserve energy, which will be needed of the world. Coming to wind energy, so wind, it's globally recognized as environment-friendly resource, and one of the fastest growing renewable energy sources, and it has huge potential. Already I told you in India, uh, we have 700 gigawatt at 120-meter height, but if you see global wind energy potential is 72 terawatt, which is more than 4 times of the current world electricity demand. That much of potential is there. Only thing, we need to tap that power. So which means wind alone can take care of the complete electricity requirement of the world. That much of potential is available, and we have very good technology. The technology is very mature and advanced technology we have in terms of converting wind into electricity, and the resource is freely available. Everywhere you can see wind, no need of paying for the resource. And if you convert wind into electricity, there will not be any pollution. So wind is not at all new to us. Many years before, we started harvesting wind for various purposes, like sailing boats, grinding grain, pumping water, and now with the modern technology development, we could able to come up with wind turbine, which can convert wind into electricity. Wind is nothing but air in motion. Because of the differential heating of the solar radiation on the surface of the earth, wind is created. If you see from this movie, during daytime, because of the sunshine, land easily gets warmed up than the water body. So land warm, which is low pressure. We know very well that high pressure will move always towards low pressure. So that's how wind is created. During night, it is quite opposite. The land easily gets cooled down than the water body. Water body retains heat for some time. So this pressure difference creates the wind. Wind energy conversion is nothing but the kinetic energy available in the wind is converted into mechanical energy by using a turbine, a rotor. Then the mechanical energy is converted into electrical energy by using generator. It is very simple. Wind has a kinetic energy because it's moving. That kinetic energy we are converting to mechanical energy by using a rotor blade turbine. Then the mechanical energy converted into electrical energy by using generator. If you see the energy efficiency, conversion efficiency, even though we have well-designed wind turbine, the maximum energy what we can convert from kinetic to mechanical is 52% only. There is a Bird's limit. According to Bird's limit, only 52.9% only the conversion efficiency. And if you see mechanical to electrical, we can go for more than 90-95% possible. This is basically for those who have not seen the wind turbine. You see the natural wind as a kinetic energy, which is falling on the wind turbine blade, which has been designed aerodynamically to take more lift force to rotate. And from the blade, we have a low speed shaft to connect to gearbox to step up the speed. And from gearbox, we connect to generator through high speed shaft. So whatever energy we are producing, which goes to the consumer via electricity grid. So this is how wind turbine works. This is the formula of wind energy, wind power. Formula is of rho A B cube. Rho is the air density, A is the area of the blade, rotor diameter, and V is velocity of wind. The velocity of wind increases, we can produce more power because it's V cube. Here, the density, air density, and wind velocity is a completely natural process. We cannot have control on it. We cannot create the wind velocity, we cannot increase the density. It's a natural process. So if at all you want to produce more power, where you have control is area. So you can increase the blade length, rotor diameter, so that we can produce more power. Based on the axis of rotation, we have vertical axis wind turbine and horizontal axis wind turbine. We normally generally use horizontal axis wind turbine for its own advantage. Because if you see the vertical axis wind turbine, already I told you, close to the terrain, ground, the wind speed will not be good because a lot of obstacles will be there. So keeping the turbine close to the ground, we cannot produce more power, and having long centrifugal effect, which will affect the components sitting inside the nacelle, like gearbox, generator, everything. So that's why our purpose is to produce more power. So that's why we generally use horizontal axis wind turbine, because it can go any height. Actually. In terms of technology, we have a fixed speed wind turbine, variable speed wind turbine, geared wind turbine. Those days we had geared wind turbine. Now the lot of the modern wind turbine comes with gearless and based on the axis, horizontal and vertical axis wind turbine. Offshore, onshore wind turbine. So we can install wind in the land and also in the sea. So these are the general the technology used in wind turbine, and you can see wind turbine with various number of blades, and like single blade wind turbine, two blade wind turbine, three bladed, and even multi-blade. So single blade wind turbine, it has to rotate very fast to achieve its efficiency. If you compare with two blade, the efficiency is 10% less. And in fact, if you see the cost of the wind turbine, we have to spend about 20% of the cost for blade alone. So it's costly. That's why earlier people thought that if you reduce number of blade, we can save some money. But to have a balance, we need to go for a counterweight, which is taking away some money, and the efficiency, if you compare with two blade, 10% less. That's why people move on to two blade, and two blade. You have this tethering effect because of the imbalance. So the component sitting here will get affected because of vibration and all. So three blade is a well balanced structure and ideal for the production of electricity, and the multi blade is used only in the water pumping windmill. because we are going to lift some force, lifting water, which needs more torque. When we need more torque, we can go for multi-blade. Here, only the conversion happens from kinetic to mechanical. So we are not going for electrical. That's why this is called windmill, water pumping windmill. So, in wind turbine, we have more than 8,000 components. These are the major components, like a rotor will have blades, hub, and aerodynamic controlling system. And there's a yaw system, I will let you know, and tower for and foundation. Drivetrain will have a shaft, brake, gearbox, generator, and all. The national frame. So to close up, see, we have a foundation, and on the top of the foundation, tower is erected. On the top of the tower, this enclosure is called nacelle, which houses all the equipment like gearbox, generator, brake, and so many other equipment, sensor, and all. And we assemble the blade. So to show you close up, the three blade is connected through a hub. From the blade, low speed shaft to connect to gearbox to step up the speed. In between we have brake, and from gearbox there's a high speed shaft connect to generator. So apart from these sensor, the equipment, we have a lot of other controlling system like oil cooling controller, temperature controller, so many sensor. So like this yellow one is called anemometer, which measure the wind speed. This red one is called wind van, which shows the direction of the wind. So apart from this, many sensors are available. The tower top, we used to have a yaw drive. I'll tell you why we are using yaw drive. Okay. So in picture, the wind turbine looks very simple, but it is a very gigantic structure. See, a typical 2 megawatt wind turbine, hub height and blade diameter, everything. It's a very big structure. So from the ground level, the tower height, hub height we used to call, as more than 100, 120. Now the modern wind turbine goes up to 200, 200 and something. So that lengthy tower we have, and the rotor diameter. So nowadays, the one single blade length itself of close to 50 meter, and the modern the latest wind turbine blade length is very big. In fact, the diameter goes more than 200 meter as well, and so almost yeah, the wind turbine structure is equal to the Boeing 747 flight, and you can see the weight, almost uh, 48 elephants if you add this 2 to 3 megawatt wind turbine weight, that much. So rotor diameter is close to 110 meter, blade length so about 53 meter, and then blade weight you see 11 ton, rotor weight 60 ton, and nacelle weight is close to 82, and the it's a big structure in fact. So can we have a small break? So we have seen the weight of the blade based on the capacity varies. So it is in tons actually. Even small breeze, 2 to 3 meter speed uh, can turn that heavy blade. How it is possible? So you can see here, the blade is designed aeronautically, almost like aeroplane technology. You could have seen while landing and taking off, there's a changes observed in the blade wing of the airplane. A similar technology used in wind as well. So this is the cross section of the blade. The wind comes and attacks, gets split up, goes like this, The blade is designed such a way that the bottom, you see, the wind touches almost all part of the blade. Top, the design makes the wind to come like this and goes. So here, it's a vacuum. Vacuum is low pressure. This side, high pressure. So we know very well that the high pressure will move towards low pressure. So that's how lift force is taken place to rotate the blade. So you can see clearly in this movie, the wind comes from this side and touches all part of the blade in the bottom. Top, wind comes like this and goes like this. So here there's a vacuum which is low pressure. So that's how rotation takes place. There is the wind turbine or design to certain wind speed, like cut-in wind speed, cut-out wind speed, rated wind speed, and survival wind speed. Cut-in wind speed is nothing but at wind speed, uh, the blade start rotates and produce power, which is almost all modern wind turbine are designed for minimum wind speed of about 2.5 to 3 meter per second. So 2.5 3 meter per second wind is there, the blade will start rotate and produce power. That is cut-in wind speed. Cut-out wind speed is 25 meter per second. So if wind speed goes beyond 25 meter per second, the wind turbine will stop for its own safety, because a lot of load will appear, vibration happens, component will get failure. That's why the turbine will stop if wind speed beyond 25 meters per second. That is cutout wind speed. Rated wind speed is about 10 meters per second. Almost all wind turbine are designed now. If 10 meter per second wind speed is there, it can go for its full capacity. Like if it is a 1 megawatt wind turbine, it will produce 1 megawatt if wind speed goes 10 beyond 10 meter per second. And survival wind speed is normally during the storm or cyclone kind of time, the wind speed will be more. So the wind turbine has to withstand during the heavy wind. That is called survival wind speed. So nowadays, the modern wind turbine can withstand up to 70-75 meter per second wind speed. So actually, here we are saying cutout wind speed. If wind speed more than 25 meters per second, it will stop for its own safety. So if you stop the wind turbine during the windy season, it's a loss for the investor. To avoid that, there's a technology introduced called pitch control. So if wind speed more than 25 meters per second, without stopping, uh, we can make a blade to go out of wind, little out of wind, by which we can still continue to run the wind turbine, and that is called pitch control. And those days, this was used for braking purpose as well. The tip of the blade alone will go out of wind, by which we can have a brake. And now the modern technology, the whole blade is going out of wind. So this can also be used as braking purpose. So I was telling the yaw control here. See, there's a yaw control, yaw drive between the tower top and the nacelle. This is used basically. You know very well that wind is in dynamic nature. So now wind speed may be 5 meters per second, after some time it will be 10 meters per second, after some time it will be 0. So varies at a time. And wind direction also changes at a time. So now it may come from east, suddenly it changes direction to west or south. So actually the blade has to face the wind, then only lift force taken place, it will rotate. So if direction changes, what we'll do, we cannot produce power. That's why there is a function called yaw control, yawing. So basically, I told you the top of the tower, the wind turbine, we have two sensor. This is a very important sensor which used for measuring wind parameter. Like the yellow one is called anemometer, which measure the wind speed. This red one is called wind van, which shows the direction. So these sensor will give a signal, like the red one, it shows the direction, and it give a signal to controller. Now wind is coming from this side, so accordingly the control will move the wind turbine blade towards the wind direction. That is called yawing. So yawing is nothing but aligning the blades towards the wind direction, so that without stopping we can continuously produce power. We use all kind of tower, like lattice tower, tubular tower. So nowadays everybody going for a tubular tower because it looks aesthetically, and it is also safety, because when we climb up for installing or repairing activity, so it will be safe inside climbing. And the material we use steel as well as concrete, and sometimes we are also going for hybrid tower, like bottom steel, top tubular, and bottom concrete, and top steel. Every option is being used in wind turbine. And those days, for smaller capacity wind turbine, we used to go for guide wire. For about 20-30 meter high, 40 meter hub height, we can go for guide wire tower, so like this. So this is how wind turbine is installed. First, we used to go for a foundation, and the top of foundation we erect the tower, and we assemble the nacelle component like gearbox, generator. Then we assemble the blade. Finally, we'll take the cabling to a substation or a transformer to transmit the power. This is how wind turbine are being erected, and wind turbine has advanced technology, and it has a good controlling system, because we are monitoring about 100 to 500 parameter like wind speed, wind direction, temperature, humidity, solar radiation. So many other parameters are being monitored. So we need to have a good controller which is available in wind turbine. And nowadays the technology has changed. It's very well advanced. Sitting from my computer, my laptop, I can control wherever I have a wind turbine. I may own a wind turbine and at America, Australia. From my computer, I can switch off the wind turbine. I can switch on wind turbine. So everything is possible with the modern technology development, like SCADA with the help of internet. Mm. So coming to wind turbine installation, wind farm development, we have to, if at all you want to have a good profit, you have to follow this factor carefully. Then only your project will give you good profit. So right now in India, 1 megawatt of wind turbine is going to cost you about 6 to 7 crore. 1 megawatt. So we are investing huge money. So if you want to get a profit, this factor has to be studied well in advance before going for installation. And one more thing I wanted to tell you here: wind industry is the only sector which has more participation from private. Now solar also coming in, and all other power plant like thermal, nuclear, hydro, the major investment comes from government. Almost all hydropower plants are owned by government, and nuclear, even thermal. But wind energy sector has more participation from private, like more than 95% of the investment from private. So the private people will always look for a better revenue out of the investment. So really, you want to get a better return. These factors are very essential. The first and foremost thing is to identify a site. You have to identify a windy location, otherwise all your investment waste. So we normally we cannot find good wind everywhere. So place to place it varies, and it may not be consistent. So to uh, the wind turbine to work, produce better power, we need a minimum wind parameter. Like annual average wind speed of 6 meter and above is the good site for wind farm establishment. So for that, first thing, we have to study a wind parameter. A minimum period of 1 year we have to do a wind resource assessment, and then only we can go for wind farm development, to go for economically viable wind farm. And after identifying a site, we have to check adequate land is available or not, because we need to establish certain infrastructure which are all very costly, like making road facility and creating a grid facility. So many other infrastructure we need to create, which or costly affair. So we have to install one wind turbine, two wind turbine. We cannot create that kind of costly infrastructure. So we have to see to that at least minimum 50 megawatt, 100 megawatt installable space is available. Then only it is going to be economically viable, and we have to check the soil condition. So as I was telling you, the weight of wind turbine, it varies in tons actually. The lifetime is about 20 to 25 years. So 25 years, that heavy structure is installed in a place. So the soil condition should be good. Otherwise, it cannot withstand. It will get collapsed. So we have to go for detailed soil study, and accordingly modify the foundation. Suitable foundation can be done actually. Then proper approach is also very essential, because almost all windy areas in India, even other countries, or in remote place. For example, you take in India, only 8 states are having potential, which are close to the Western Ghats, where we have a lot of mountain passes, which gives the tunnel effect, by which we get good wind. So all those remote places, we will not have any facilities. So we have the to transport, like you see, a lengthy blade, one single blade length, it's about 50 meter, and if you to transport this, the local roads cannot support. So we have to see. And if you see, if you go to the top of the hills, always you can feel a very good wind is there. So if you put up a wind turbine, you can generate power, more power from wind. But we cannot install on hilltop because logistic problem. We cannot carry all the component to top of the hill, and because of which we were unable to. So a road facility is another important aspect we have to look into. And next is power grid should be available. So whatever wind turbine you are going to install, after installation, when we start producing power, it has to be evacuated, it has to be transported to needed places, for which the grid, electricity grid, is very essential. Many places, even those days in India itself, people were ready with money to install wind turbine, and some places they have installed also. So after installing, if you find there is no grid, it will be waste. The investment will go waste. We were talking about China is number one in wind installation. In fact, they have more than 200 gigawatt wind install capacity. But people, I don't know exactly, but people used to say they simply install wind turbine. They have not connected to the grid. So unless you connect to the grid, you cannot produce power. So if you are not producing power, you cannot get back the money. So that is a waste of investment. So main thing is grid. The grid should be there, because still some places uh, uh, they install wind turbine. Due to non-availability of grid, they are asking to shut down the wind turbine. If you go to the wind farm area, the people will be familiar with the term called shutdown. So if we have one region, they will allow you to generate power and connect to the grid. Some region they will stop, just a non-available. That kind of facility is waste for the investment. The investment will go waste. So we have to see to that the grid is available to take care of all your power what you're going to generate. Then who is going to buy your power? So you are investing into huge power like 1 megawatt, 2 megawatt, 3 megawatt. Uh, when you have a lot of power generating, so who is going to buy? You cannot use all the power what you produce, and basically you have to sell it to somebody else. In fact, in India, each state has electricity board. Uh, they've been buying all this power. Like, for example, you take yeah, each state has an electricity board. They are buying the power. In fact, 2003 Electricity Act has given a lot of provision to buy the green energy sources. Like they started giving a preferential tariff for the power what we produce from green energy, renewable energy sources. So each state has its own policy in terms of fixing the price. Like for example, you take Tamil Nadu, they are giving 3 rupees or 3.5 or 3.8 rupees per unit of electricity produced from wind, and some other state even give 4 rupees, 5 rupees, even 6 rupees. Based on so many criteria, they fix the Central Electricity Authority will fix a tariff, and the electricity board will buy. And some state has a policy, you can also sell it to third party. So you install a wind turbine. You may have your own factory which need more power, so that power can be utilized. If excess power is there or you don't need, you can sell it to third party. Your friend or somebody will have a factory, they need power, so you can sell it to them. But by using the electricity board grid, you have to pay some money for wheeling. So you're wheeling the power. Apart from that, so many other facilities each electricity board has, and like any other project, techno-economic study has to be done for going for economic viable project. And operation maintenance also is very essential, because as I said, all the windy locations are very remote place. Uh, in that remote place, you're going to install a heavy structure, not only transporting from other place, installation, commissioning. We need to have a certain facilities like big crane. So from the ground level, the now tower height is about 100 meter. So above top of the 100 meter, we are going to install component like gearbox, generator, blade, and all. So we need bigger crane, which may not be available in those rural remote places. So we need to see to that it is available for installation, commissioning, and also during the operation. So during windy season, your wind turbine is ready enough to produce power. Then only you can get back the money. So if something goes wrong, so immediately it has to be rectified. So sometimes you can climb up and rectify. Some problem happens, you have to bring it down, rectify or repair and refix it. So for which the bigger crane is needed, and also trained manpower. So locally, the trained, skilled manpower may not be available. So we have to create such a infrastructure or benefit by which the skilled workforce is readily available in those remote places. And if you take care of all these things, definitely your project will be a economically viable one. So being said, the wind resource assessment is the first and foremost thing to do before developing wind farm. We have to measure minimum a period of 1 year the wind data, uh, average annual wind speed, average annual direction data, and short-term variation. Different height has to be collected without having discontinued the continuous data for a year. Then only we can analyze and say any given location is having potential or not. In India, April to September is the windy season because of the strong southwest summer monsoon, and some places we can also find weaker northeast winter monsoon. But the windy season is April to September for India. So we studied wind parameter from 1986 onwards, and a different height like 20 meter, 50 meter, up to 120 meter now, and based on that we have come up with the wind atlas. See, this is the structure we normally conventional method of measuring wind parameter. This is called meteorological mast, which will be installed in different selected location. For selecting location, we have different factors. And this met mast, we used to instrument these sensor like as I told you, these two important instrument, the anemometer, which measure the wind speed, this one the wind van which shows the direction. So these are the two important sensors. Apart from that, we have temperature, humidity, rain, the solar radiation, all these factors will be measured. And this is called data logger, which will be kept in the bottom of the mast. So whatever data comes from these sensor installed in different interval, like if it is 100-meter mast, we install at 100 meter, 80 meter, 90 meter, 70 meter. All this data will get stored here. Micro the With the help of microchip, we collect. We have specialized software to analyze and say any given location is having potential or not. This is the conventional method of measuring. So nowadays, the latest equipment have come, equipment called SODAR. It is a sound detection and ranging. This works with the help of Doppler effect. By emitting sound beams into atmosphere, we can measure wind speed, wind direction data. Like this emits sound, and the other one is a received sound. So we can measure. This is in fact a portable equipment. We can carry wherever you want. But the midmast is a time-consuming and fixed structure. This portable we can carry anywhere. So this can measure wind parameter up to 1 kilometer, 1,000 meter we can measure. But going with this midmast certain height beyond, which involves a lot of money, a lot of structural design, and it occupies a lot of space. So this can be used for at higher height at any given location. And latest is LiDAR. It's light detection and ranging. By using light beams, we can measure wind parameters. By using LiDAR, we can measure vertically as well as horizontally. And LiDAR can give you a higher height at any given location. And latest is LiDAR. It's light detection and ranging. By using light beams, we can measure wind parameters. By using LiDAR, we can measure vertically as well as horizontally. And LiDAR can give you accurate measurement. This is being now used largely to measure wind parameter. And based on these sensor equipment, we have measured all over India, more than 9,000 locations. We have established wind monitoring station, and based on the collected data, we have come up with the Indian wind atlas for India, which can give you a fair idea. Like if you ask me at your native place what is the wind speed, you have to give me latitude and longitude. So with the help of wind atlas, I can tell you this is the wind speed, wind direction data. So these are some of the largest wind farms available in India. Wind installation, Tamil Nadu is #1, having more than 9,000 megawatt installed capacity, and Tamil Nadu is having a biggest wind farm. One place called close to Kanyakumari, Cap Tamarin. There's a place called Muppandal, where one single location we can find 1,500 megawatt wind turbines of various capacity, starting from 225 kilowatt to 500 kilowatt, 750 kilowatt, 1 megawatt, 1.5, 2 megawatt, our latest one 3 megawatt. So all different kind of wind turbines are installed. So you can see when you happen to travel down south to Kanyakumari, you can see this kind of wind turbine actually. It's like coconut trees. It looks very nice to see. And Rajasthan, there's a place called Jaisalmer. We have a big wind farm, and Maharashtra, Brahmanvale, and Karnataka, Chitradurga, and these are the biggest wind farm available in India. And based on the data, what we measured using MetMast and the LiDAR solar, these are the wind estimation we have done actually, state-wise wind estimation. So at 50-meter height, there is a possibility for going for 50,000 megawatt. At 80-meter height, 1 lakh megawatt is possible, and at 100-meter height, 3 lakh megawatt potential available, estimated. 120-meter, close to 7 lakh megawatt. So these are the wind potential map what we have prepared based on the actual measurement compared with the, this thing. And this all the state, 8 states are having a wind deployment in India. This blue one is called estimated potential. This green one is installed capacity. So as I said, Tamil Nadu is #1, having more than 9,000 megawatt installed capacity, and this is the first wind turbine installed in India way back in 1986 at a place called Mandvi at Gujarat, and Tamil Nadu, Gujarat, Maharashtra, Odisha. These 5 states, the wind turbine installed in during 1986. Smaller capacity, very smaller capacity of 55 kilowatt wind turbine with a hub height of about 20-25 meter high. Now the capacity increased over a period of time. Like when we started with 55 kilowatt wind turbine 1986, gradually the capacity increased. Now in India itself, one single wind turbine can go for 3,000 kilowatt or 3 megawatt capacity. But in the world, we have a higher capacity wind turbine of 10 megawatt and even 14 megawatt. Recently, Vistas has come up with a 14 megawatt wind turbine. So in picture, it looks very simple. You can see from the ground level, the hub height is more than 200 meter. The even rotor diameter, one single blade is close to 100 meter length. So a very big structure. And if we compare the cost with the conventional power plant, okay, those days we used to say thermal, hydro are the cheapest power source. Now wind is becoming cheaper, and you can see many places are cheaper than the conventional power plant. And if you see the cost of the project, close to 83% of the cost overall what we spend, we have to spend for the wind turbine. And to create infrastructure, 10% cost is going. For land, only 2%. And other processing charges 5%. So out of 6 crores, 20 lakh, this is the split up what we spent for the project. And this was a component wise cost. As I said, 20% for blade, tower for 24%, and gearbox 11%, and all other things. This is how we are spending cost for the wind turbine. So this is the technological upgradation happened in India. I told you in 1986, the 55 kilowatt wind turbine was installed, and now that 55 kilowatt wind turbine, the hub height was about 25 or 30 meter, and now highest wind turbine has gone more than 140 meter. Then rotor diameter, earlier it was about 15 meter dia, now more than 100 meter dia wind turbines are available. Those days we had only fixed speed wind turbine, now variable speed wind turbine all introduced in the market. Those days we had only geared wind turbine, now gearless technology came into the market, and we have done a lot of changes in the blade in terms of design, material to increase the strength and efficiency, and the capacity I already told you. So indigenization is now up to the level of 80%. Those days we used to simply import from other countries, European countries, and assemble and sell it. Now almost 80% of the components are being manufactured in India. So we'll be going for 100% coming years. And this is about the manufacturer available in India for wind turbine. So we have right now 20 large wind turbine manufacturers available in India. Almost all global leaders are having their base in India, their factories for production of wind turbine of various capacities starting from 225 kilowatt to 3 megawatt. These are the wind turbine manufacturer and their capacity available for installation. In India, we have a ministry called Ministry of New and Renewable Energy. In fact, India is the only country is having a separate ministry for the promotion of renewable energy. No other country has a special ministry like us. They may have a Ministry of Electricity, a Ministry of Energy, a Ministry of Agriculture, under which there will be a small department to look after renewable energy promotion. India, in the year 1992 itself, we have come up with a special ministry called Ministry of Non-Conventional Energy Sources, and that was renamed as Ministry of New and Renewable Energy in 2017. So this ministry is the nodal point who support for the renewable energy in the country. They are coming with a lot of schemes which promote the renewable installation, and they also established a specialized institution for all renewable energy sources. Like solar, we have a National Institute of Solar Energy at Gurgaon, and for wind, we have a National Institute of Wind Energy at Chennai, and for bioenergy, we have an institute called National Institute of Renewable Bioenergy at Punjab, and they also established an institute called IREDA, Indian Renewable Energy Development Agency, to support the financial support for renewable energy project. So that's how we are in the top 5 countries in terms of renewable energy sources. Not only central government, state government also supports the wind energy development in each state actually through different policies like tariff, infrastructure development, concession, and import, export, and all other things. So this is the advantage of wind energy. So as I told you earlier, the resource is freely available. No need of buying coal. You have to mine, spending a lot of effort, money, time, or otherwise you have to import from other countries. But wind, no need of putting that much effort. The source is freely available, and I already told you the potential. We have huge potential, more than 72 terawatt, which is more than 4 times of the current world electricity demand. That much of potential is there, and the technology is very advanced for conversion. And another advantage is lowest gestation period. You take any other power plant like thermal, nuclear, hydro, it takes minimum 3-4 years to plan, install, commission, and start operating. Wind energy, if money is ready, within a month we can install wind turbine. That's what attracted the private people to jump into wind energy sector. And the cost already showed you compared to conventional power, it is coming down. And O&M cost also very less. Just 2% you have to spend for the operation maintenance, and it takes limited land like thermal, nuclear, hydro. They take thousands of acre of land, but wind 1 megawatt. We may need about 24 hectares. Now with the modern technology development has brought on, even 4 5 acres we can go for 1 megawatt installation. Now another advantage is it can accommodate many other activities between two. So between two wind turbine, we can do a lot of other activities, like even agriculture is possible, which is not possible with any other power plant. And it has created a lot of employment opportunities, and I can show you coming slides. And the bottom, these two things are very important advantage of wind, because we have seen CO2 emission is major cause for all the environmental impact. So if you use 1.5 megawatt of wind turbine, which is going to eliminate 2,700 tons of CO2 every year. Imagine how much of installation happen, how much potential is there. If you start installing wind turbine for our power requirement, definitely we can mitigate the global warming climate change issues by avoiding CO2. And another important advantage is it saves drinking water. Yes, normally we all other power plant like thermal, nuclear, hydro, everywhere we use water. You know how we produce electricity. Electricity is nothing but flow of electron which happens inside the generator. So magnetic force, we are cutting the flux, then for the flow of electron happens. To cut the flux, we use a shaft inside the generator. We have to rotate the shaft through turbine, and to rotate the turbine we use different sources like hydro. We use water. Goes forcefully and falls on the turbine because of design rotates and we produce power. Nuclear, what we do, because of the fission or fusion, heat is generated. That heat is used to boil the water. Water becomes steam, which goes and rotate the turbine where we produce electricity. Coal-based power plant also similar. We fire the coal to boil the water. Water becomes steam, which goes and rotates the turbine. So everywhere we use water, but the wind turbine, the natural wind rotates. So we are not all using water. So you know the importance of water nowadays. Every we open WhatsApp, a lot of messages are coming, and a lot of reports says after a few years this region will not have water, that region will not have water. So in that kind of situation, if you go with the wind turbine, we can save a lot of water. So really, wind can mitigate the global warming and climate change issues. And the wind turbine, we cannot say disadvantage, we can see limitation. So it is really site specific. So we cannot install wind turbine wherever you want because we need minimum wind parameter. So otherwise it will not be economically viable. So that is the only thing. And it is an intermittent source, so inform nature. Now it may be 5 meters per second, after 5, sometime 10 meters per second, after sometime 0. So that is the only difficulties what the limitation is seen in the wind industry. But now the modern advanced technology can address this issue. Now like rain, we can predict the wind 1 hour after, what would be the wind 1 day ahead, 1 week ahead, 1 month ahead, what would be the wind. So that is possible. In fact, we ourselves doing in India, it is working better. So this will be a good option for this intermittent source. And some few environmental issues people are talking about, but seeing the big advantage, all these things are very minimal, and with a proper planning, you can avoid all the environmental issues people are talking about. So it is not a big issue, and we can go for small wind turbine and your rooftop. So whatever power comes, you can use for your own purpose, and can be fed to the grid also. And we can go for high water pumping, windmill. We can go for hybrid system like combine wind with solar, wind with diesel, and so many other resources. This hybrid system will be very useful for the remote place where there is no grid at all. even a island, taking grid from mainland to island is very difficult. Those kind of places, hybrid system can be a good option to have a continuous power supply. And offshore, now every country is going for offshore wind installation because they do not have a land facility. uh, Almost 20 gigawatt installed in offshore in many countries like China, UK, German, Denmark, and all. India also working on, because we have estimated potential of about 700 gigawatt, but what we have achieved about 20 to 30 percentage. So we have a lot of untapped land-based potential, but still we are going for offshore development to go along with the world. And as I said, we have three sides of sea, like Bay of Bengal, Indian Ocean, and Arabic Ocean, and where we have a long coastline, 7,600 kilometer coastline. But some places like Odisha, Andhra Pradesh is prone for a cyclone kind of thing. But some places are having a very good potential, like Tamil Nadu near Rameshwaram to Kanyakumari, and Gujarat. There is a possibility. A lot of study are being done. Maybe coming years we will have offshore wind turbine in India. Sorry. So offshore there is no land issue, and the surface is very smooth. We can have a more production because of predominant wind due to surface, smooth surface, and there is no noise problem. But we have to invest huge money, like almost double the cost of land. What we need to spend a lot of money for the foundation and cabling will take more money. And the environmental issues, what I was talking about, is noise and shadow flickering, and sometimes visual impact and electromagnetic interference. So all these issues can be avoided with the proper planning, and which has been studied in detail, and people have reported wind turbine is really support someone. There's no impact on the So even though we have installed more than 40 gigawatt wind in India, and having 20 large wind turbine, I'm audible, sir.
Yes, sir, you're
Yes,
audible.
sir.
So we have a lot of challenges to face. Basically, connecting to the grid, because inform nature, variable variability, because sometimes comes, sometimes goes. So connecting to the grid will always face problem. So we have to address this. But a lot of studies have done, and still people are working on it. And as I said, the indigenization is up to 80%. So we'd like to come up with our own design which suits for Indian climatological condition. And all windy locations we have already filled with the the smaller capacity wind turbine. Now we have to go with the higher capacity wind turbine. And all high wind location already wind turbine are installed. Now what is available with us is low wind regime. So we need to work together along with the special institution, universities, colleges, to come up with a better design which can work better in low wind regime. And the forecasting I was talking about is another area which has a lot of challenges. And storage, now the hot topic, everybody is working on it. So if really you want to go the 100% renewable energy, storage is very essential, because the source is not available always. For example, we take solar, it is available only in daytime, and wind is available for some time, sometimes it is not available. So whenever it is available, you have to generate and store it, and when it is needed, we can dispatch. And offshore for India, it is a big challenge because a lot of investment has to go in, a lot of study has to be done, because it should not affect the fisherman activity. We have to use a special material to avoid the corrosion, and we have to do eco or the ocean eco study, where the animals living in the ocean should not get affected, and tide should not affect. All those studies has to be done. And human resource, another area, because we need a lot of trained, skilled manpower to take care of the wind development in India. As everybody is talking, renewable energy is going to be future, because when the fossil fuel is damaging the environment, we have to change and to the natural resource which has good potential. So to go in a big level, we need skilled, trained manpower, and this is what you call net metering. See, you can put up. Sorry, rooftop, you can go for solar panel and small wind turbine. Whatever power comes, you can use for your own domestic purpose, and extra power can be fed to the grid, which is net metering concept introduced all the states in India. And excess power can be used for desalination and can be charged. The car battery can be charged by using excess power. Coming to the carrier, wind energy is a highly interdisciplinary subject. Uh, which need almost all engineers to work on. To design blade, we need aerodynamic engineer. We have a lot of mechanical or electrical component. We need those people. Tower foundation need civil and structural engineer, and the blade material need chemical engineer, composite material, and for the wind resource assessment, we need physics. Almost all engineers are needed for this sector, and uh, there was a study done by California University which says compared to the conventional power plant, wind sector has given a lot of opportunities, job opportunities, because we need about 15 to 20 manpower for 1 megawatt, 5 direct engineer, and 15 indirect people like marketing, selling, production, all. So totally about 15 to 20 manpower for 1 megawatt. You can imagine how much potential available, how much install capacity. So the IRENA, International Renewable Energy Agency, has published a report. More than 11 million people are already working in renewable energy sector, and that wind more than 1 million jobs available, and about 32% the people who work in renewable energy sector are women. So each center has opportunity to work in wind energy sector. In fact, the prediction says in another 30 years, 2050, Asia is going to play an important role in renewable energy, and huge manpower is going to be employed in sector, wind energy sector. In fact, we can find opportunity in R&D area, manufacturing area, assembling, testing area, sales and planning, transportation, installation, maintenance area. So one can find opportunity in design area, various components like blade and other components, and one can find opportunities in installation commissioning area. You can find opportunity in operation maintenance area. So you see this picture, the tower height is from the ground level more than 100 200 meter. The top of the tower, people are walking very it's a very fascinating area to work, in fact, in wind sector. And as it is related to environment, even environmental engineer are also having opportunities in this sector. And this is about my institute where I come from, National Institute of Wind Energy, established in the year 1998. as Center for Wind Energy Technology, CWET, but now it has been renamed as National Institute of Wind Energy in 2014. The institute established as autonomous R&D institution by the Ministry of New and Renewable Energy to take care of the technical requirement of this sector. And in fact, our objective has been set to take care of the complete wind power development in the country. We are into A to Z. We do wind resource assessment, research and development, testing and certification, and training. As we are the only institute of its kind in Asia, perhaps developing countries, we have huge responsibility in disseminating the right information to the right user at right time. So we also do a lot of training program on wind energy. So our institute contributes to all the category of people, like supports to the developer, investor, providing authentic information and certification. It supports academic people, providing library facility, publication, training courses, and the master level syllabus and HRD program, and also for general public to promote the green energy sources, creating awareness. So let us all join our hands together to create save only motherland earth. With this, I close the presentation. Thank you all for your patient hearing, and I hope I've given you some useful information. So if you have any questions, please feel free. So I'll be available to answer your question. Thank you. Any questions? Dear participants, any questions?